we are looking at equivalent relation. So a relation in a set A is said to be equivalent relation if R is reflexive, symmetrical and transitive. If it holds all of these properties, then it's said to be equivalent. Okay, so let me pick up an example. Let T be set of all triangles in a plane with R a relation in T given by, well, R is defined as T1 comma T2. It picks up order pair wherein T1 is congruent to T2. So let me explain it this way. We have a plane with all the possible triangles, whatever you can imagine. All those have been drawn over here. Now, the relation will pick up triangles with the condition that they are congruent. So first thing first, let's talk about reflexive. We'll let pass the reflexive. What is reflexive? Well, our element should be related to itself under the relationship R. So in this case, is a triangle related to itself? Yes, a triangle is congruent to the same triangle. So I can put it in this way. A triangle is congruent to itself. Right? If I copy paste this triangle, so these two are congruent by default. Next, symmetrical. Now we have A1 or A and B, say it belongs to R, then B and A should also belong to R, right? So this is symmetric. If this is happening, this should happen. So we've seen cases wherein this will not happen, right? So if I am relating a value like say 2 and 4 or say 6 and 36. So first value is a number and the other value is a square of that number. 36 and 2 or 36 and 6 will not be related. In this case, let's see. So we have say triangle 1 is congruent to triangle 2. By default, triangle 2 will be congruent to triangle 1, right? So here we have T1 being related to T2 and T2 being related to T1. So in both this cases, the relationship holds good. So it's symmetrical. And at last we have transitive. So it deals with A and B belonging to R and B and C belonging to R. And now we have B is common, A and C should belong to R. Right? So let me use a example. Say I have this triangle and one more triangle which is going to be the same, congruent. So this two are says congruent. Okay. So this two are congruent. I have one more pair, this being the first, and imagine that they are congruent. I might not be successful in doing that. So they look almost like congruent. Agree? So this two are congruent. This two are congruent. So by default, the first and the last are congruent. Does it make sense? And this is your proof. Not exactly, this is not the way we're going to write, but yes, this is a good example of equivalent relation. So see to that you copy everything, make use of colors and all of that, make it look good.